There's something that we know about it, and that is at the x-intercept. This is where the graph is going to cut the x-intercept, the x-axis. So it means at this x-intercept, y is equal to 0. So at the x-intercept, y is 0. So in order to work out and know that x-intercept, therefore, we are going to say now this function that we're given is y part is going to be 0. So meaning this is 0 is equals to 5x over 3x minus 1. And we're gonna multiply both sides by 3x minus 1. And also on this 3x minus 1, you can now see that this particular part and this part will cancel out. We end up having 5x is equal to 0. And that will mean that if we divide by 5, we divide by 5. This implies that our x is going to be 0. So at the y-intercept, at the x-intercept, welcome to another tutorial of Profland YouTube channel. In this particular video, we're going to have a discussion how you can be able to sketch this kind of rational function graphs. So for instance, at this point, we are given an equation y equals to 5x over 3x minus 1, and then we are supposed to determine the sketch of this graph. So whenever you're given a question like this, the first thing that you ought to know here is that we need to know what is the y-intercept and what is the asymptotes for this particular graph. So number one, let us look for the x-intercept. Then we shall go ahead also find the y-intercept. Remember, at the x-intercept, there's something that we know about it, and that is at the x-intercept. This is where the graph is going to cut the x-intercept, the x-axis. So it means at this x-intercept, y is equal to 0. So at the x-intercept, y is 0. So in order to work out and know that x-intercept, therefore, we are going to say now this function that we're given is y part is going to be 0. So meaning this is 0 is equals to 5x over 3x minus 1. And we're gonna multiply both sides by 3x minus 1. And also on this 3x minus 1, you can now see that this particular part and this part will cancel out. We end up having 5x is equal to 0. And that will mean that if we divide by 5, we divide by 5. This implies that our x is going to be 0. So at the y-intercept, at the x-intercept, x is going to be 0. So meaning that the coordinate for that point is going to be 0, 0. Now, the next thing that we need to know before we start sketching this graph is determining also the y-intercept. The y-intercept in this case, at the y-intercept, x is always equal to 0. So meaning for us to find the y-intercept, we're going to say this is going to be y 5 times 0 over 3 into 0, and then this is going to be minus 1. So basically, we are going to end up having y is equals to 0 over -1, and basically that's going to be 0. Also the y-intercept is going to be at the point 0, and that will mean that the coordinate for that y-intercept is going to be 0, 0. So the next thing that we need to find is the horizontal and the vertical asymptotes. So now we shall start with the vertical asymptote. Now, finding the vertical asymptote is when we have the denominator is equals to 0. At the vertical asymptote, denominator is equal to 0. So meaning this is going to be 3x minus 1 is equal to 0. So 3x equals to 1, x equals to 1 over 3. And now at that particular point, we can even start now looking how our graph is going to look like. Our graph is going to have the x and the y axis like that. So at x is a third. So if we say that this is 1 and this is 2 and this is 3, then our vertical asymptote is going to pass through that particular point. So this point here, we're going to say x equals to 1 over 3. Then for the uh, horizontal asymptote, the horizontal asymptote is going to be obtained by, because the degree of the denominator and the degree of the numerator are equal, so we're going to say that the horizontal asymptote is going to be actually 5 over 3. Y is equals to 5 over 3. So we are going, basically, we are just taking the 5x over the 3x that we have here, and this cancel, we have 5 over 3. So you need to check the different rules that we usually follow when we are stating the horizontal asymptote. This is actually horizontal. Let me write it properly. Horizontal asymptote. There are rules that we're going to use here. Number one, that if you need to know that if the top degree is less than the bottom, then you are going to say the horizontal asymptote is going to be equal to 0. If the top is less than the bottom, you are going to say the asymptote is equal to 0. But if the top is equal to the bottom, you are going to just pick those values the way they are, and then you say that's going to be the fraction for that case. And let's say this is 1 and this is actually 2, so meaning our 5 over 3 is going to be along that particular point. And in the case whereby if you have the top degree of the function is greater than the bottom, so it means there is no horizontal asymptote. So those are some of the rules that you ought to know. Now let's go back. 0 0, x-intercept is going to be 0 0. Y-intercept is going to be also 0 0. X-intercept, we got it to be 0 0. Y-intercept is going to be 0 0. So meaning that our graph will pass like that. Our graph will behave like that. And also on the other end, this graph is also going to go that way. So it will approach the graph will approach the asymptote, but it will never touch that particular asymptote, and that's exactly what we are going to have. So now from this point, what I need to do, I need to go and take you into Desmos so that we can be able to see, is it true this graph is going to behave like this? We try to sketch this in Desmos and get to see how the graph gonna look like, and compare it with the sketch that we have obtained. So I need to take you quickly here to Desmos so that we can be able to see how this graph is going to look like, and we get to appreciate the fact of exactly what we've done. So let me just try to open Desmos, the graphing software, so that we can see what are the features this graph has, and what was expected. So here we are in Desmos. Okay, just give me a minute so that I All right, so remember our function, the function that we have just drawn. Let me just y equals to y equals to our function was y equals to 5x. So this is going to be 5x, and the denominator we were having 3x minus 1, 3x minus 1. Yeah, so you can see the graph that we have just obtained. Yeah, so in Desmos, this is the graph we have just obtained. And because according to the graph that we have here, you can realize that this graph is actually passing through the origin. You see the graph is passing through the origin, and in comparison with what we were having in our graph there, you can be able to see at this given point here, this graph is passing through this point at the origin, and then this is the horizontal asymptote, and then we have the vertical asymptote. So at any given point, you can be able to sketch these graphs, and once you have sketched the graphs, you can be able to test them with this uh, software that is called Desmos, just to confirm whether your graph shape is correctly done the way we have just shown you here. So just to run you through, because just to run you through according to the software, you can see now this is the graph. Along this point where the graphs are not meeting, there's a discontinuity where we have the asymptote, vertical and horizontal asymptote. So the important thing that you need to do whenever you are sketching these rational graphs is or functions is to determine the x coordinate and also determine the y coordinate of them. Okay, you determine the x-intercept and also the y-intercept, and come up also with the vertical asymptote and the horizontal asymptotes. So we're gonna stop there, and looking forward to see you again in the next video.